All right, graph number one, looking for vertical and horizontal asymptotes. You could find X-intercepts, but I didn't ask for them, so it's fine if you didn't find those. So for vertical asymptotes, what are those about? Okay, these vertical lines, right? What are they saying? They're saying these x values, whatever x value the vertical asymptote goes through, this x value is bad, okay? And what could be bad in a function like this? If the denominator of a fraction is 0, these functions all have fractions in them, and the fraction goes wrong when the denominator is 0. And that happens in this case when the denominator x is 0. It's all there is to the denominator is 0. So if x is 0, we have a problem. So let's draw a nice big vertical asymptote right through. All right, then the horizontal asymptote. Remember, this has to do with when x gets to be big. What happens when x is very, very big? You can actually plug a number in for x that's very big and see what happens, or I can just think, what's going to happen when I put -2 over some big, big number? -2 divided by 1,000,000,000 is going to be very, very small. Okay, so this is going to be small. What happens when I take a small number, a number that is almost 0, and I add 1 to it? What's going to be almost 1? It's going to be close to 1. So we're going to have a horizontal asymptote at +1 because we have that +1 there, and when x is very large, this piece is so small that it just doesn't amount to much at all. Okay, so we have those two things. We can just forget about the x-intercepts if we want to, or we might wind up finding it, but by plugging in points. So just plug in some points. We can plug in about -2 and +2. So -2, that's -2 over -2 plus 1, that's 1 plus 1, that's 2. -2, and we get 2. Okay, about 2, that's -2 over 2 plus 1, that's -1 plus 1, that's 0. So that gives us a 0, so we happen to find the x-intercept as well. There's the x-intercept, there's a point up there. Okay, so what's going on here? Does the graph go down like this? No. Well, I suppose it could, because we didn't find the x-intercepts, but we happen to find the x-intercept, there's only going to be one of those. Let's see, how do we know it doesn't go down? Well, if you have experience with these functions, just something over x, we know, like x to the first power, we know that it has just two components, and they're kind of mirrored of each other, symmetric. If you weren't sure that I guess you could find the x-intercepts just to make yourself feel better, but this simplest of rational functions is going to graph like this. They're like in opposite corners of each other. Should fix that a little bit. Okay. All right, let's look at the next one. We're going to find, let's just start at the beginning, x-intercepts. That's the first thing it mentions. X-intercepts, that would be where we have a point on the x-axis, right? That's where y equals 0. So that means that this, put stuff in here, and what comes out is y. The entire thing is y. So what will cause that whole fraction to be 0? We can even use our experience now solving these equations. Multiply by the denominator on both sides, you get 3x plus 6 equals 0. X equals -2 when you do all the work. So x-intercept at -2. Right? Vertical asymptotes. Okay, so that will be when the denominator equals 0. We talked about in the last problem. So when x squared plus 3x minus 4 equals 0, it's going to factor as x plus 4 and x minus 1. X equals -4 and x equals +1. Those are our vertical asymptotes. Right. Make sure I got that right. -4. Yeah, okay. Got x-intercepts. Let's look at the horizontal asymptote. What happens when x gets very, very large? You could do it yourself, but you know, if you plug in something very, very big, we just remember that +6 is not going to be a very big deal. -4 is not going to be a very big deal. When x is 1,000,000, either is 3 times x. That's not even going to be a very big deal. So we pretty much just have 3x over x squared. Do these things actually cancel out? Of course they don't. they just become so insignificant when x is large, we can kind of ignore them, okay? For the sake of finding the horizontal asymptote, we can completely ignore them, because the horizontal asymptote is going to approach whatever 3x over x squared approaches. If I just had 3x over x, the common factors of x and x, leaving an x down here, would cancel. 3 over x, when x gets very large, this would go to 0. So horizontal asymptote at 0. So our graph is going to touch the horizontal asymptote, and as we've talked about many times, that's just fine. Found the horizontal asymptote, and so now what we should do is find some points. We should choose some points that are between x-intercepts and vertical asymptotes to the right and to the left. So here, 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 and here. So let's do -5, -3, 0, I like that 0 happened to fall in here, and 2. Alright. So I'll do -5 for you, and then I'll pause it and just find all those values and not make you watch. So 3 times -5 plus 6 over -5 squared plus 3 times -5 minus 4. That's -15 plus 6 over 25 minus 15 minus 4 equals -9. 25 minus 15 is 10, minus 4 is 6. So -3 halves. -3 halves. So we have the point at -4 and -3 halves. Alright. Oh no, that was -5, excuse me. -3 halves. I'll just fill in the rest here. I'll pause the video. Alright, so I found the rest of the points. We have a point at -3 3/4. 0, -3 halves. 2, 2. Now let's start over here. I know that it's not going to cross the x-axis. We found x-intercepts, so it's going to come from down here up to here. Took a little bit too sharp of a turn there, but it's good. We know that our graph is going to go through this point, through this point, through this point, and it'll continue down, because to go up would mean to go through the x-axis, and we don't have any x-intercepts. Here, we know it's going to come from up here, curve down, approach the horizontal asymptote. Next, let's find these things. X-intercept, okay, so that happens when the numerator is equal to 0, we discovered in the last problem. When it's equal to 0, I'm going to divide both sides by negative. That makes things a little easier. 4x squared minus 11x minus 3 equals 0. Do a little work here. You get 4x plus 1 times x minus 3. That gives us the, that's the factorization, right? And then we set each of them equal to 0, and we find that x equals -1/4, x equals 3. Those are the x-intercepts. There we go. Now in red, we'll do the vertical asymptotes. That's what happens when the denominator is equal to 0. X plus 2 to x minus 1. Yep. So x equals -2, x equals 1. Those are vertical asymptotes. Okay, horizontal asymptote. What's going on there? Horizontal, I guess I should have underlined. Okay, so again, when we put in a very large number, this 3 up here doesn't add a lot. This plus 11x does not add a lot, because this -4x squared is so large in magnitude that we can almost ignore those. We can ignore those when we're looking at the horizontal asymptote. Same thing down here. We're going to look at the highest power, the numerator and denominator. So when x gets to be very large, I mean, you could try it yourself. Just plug something into x in this function, and then plug something in for x, some very big number, in for this function with all this stuff still included, and these two things will be relatively close, right? They'll both be, you know, in the billions or trillions or whatever. They won't vary by much, seeing as they're so large. Even if they're like a million off, when we're in the trillions, a million is not that much. So anyway, what will this approach as x gets very large? Well, any x in this fraction, just x squared will cancel, and we get -4. So we're going to approach -4 the larger x gets. The larger x gets, the closer the y value is to 4. Sorry, negative 4. And we'll go ahead and erase this stuff so we can see again. And we'll find some points. X, k of x, we'll choose over here somewhere, so like negative 3, negative 1, 0, I like 0, 2, and to the right of this, what is it, 1, 2, 3, 4, 4. Alright, I'll find all these while the video is paused. Alright, I changed from negative 3 to negative 4 because the negative 3 gave me negative 16.5, which is really far down there, but negative 10.5 is not too far. So negative 4, negative 10.5, so negative 5, 6, 7, 8, 9, 10 and a half, negative 4, negative 10.5. Alright, and the vertical asymptote continues down here, so let's just go ahead and complete this part of the graph. We know it's down in here because it doesn't cross the x-axis, no x-intercept. Alright, negative 1 and 6, negative 1 and 6, 0 and negative 3 halves. So it's going to go through here, through this point, and continuing down. And here, we need to know, what's going on. So we plug in 2, we get 2 and 1/4, 4 and negative 0.9444, so almost negative 1. So it must come down like this, curve through here, and go like that. So that's a good looking graph, if I don't say so myself. Simplify the rational expression, so that means we're going to look for common factors. So let's factor both of these, n plus 3 times n plus 5 over n plus 5 times n minus 5. The common factors of n plus 5 cancel, and we're left with n plus 3 over n minus 5. Some of you I still saw cancel out these n's. That makes kittens cry. Be careful, those n's are not common. What? Factors. Factors. Let me show you why I can be so sure that these are common factors. It's because they're multiplied by the rest of the stuff in the numerator denominator. In other words, I could write it as n plus 5 over n plus 5 times n plus 3 over n minus 5. If I multiply these two together, I'd multiply straight across. There's the numerator, straight across. There's the denominator. N plus 5 divided by n plus 5 is 0. Okay? Not that the n's cancel each other and the 5's cancel each other, but n plus 5 cancels n plus 5. They divide each other to 1. Times this gives us the final answer. In the case of this fraction, the n's don't cancel each other. They can't cancel each other because I can't divide n by n here. See, I can't write it as n over n times like 3 over negative 5, because that's not the case. If I were to multiply these together, I get 3n over negative 5n. That's not what this is. Right? So they have to be multiplied together in order to cancel them out. They have to be factors, and n is not a factor here. But n plus 5 is a factor of this fraction. We'll have the numerator and denominator. Okay, so again, we're going to, since we're multiplying, we'll multiply straight across. This becomes one big fraction. We'll just factor the numerator and denominator. X minus 4 times x plus 4 times x minus 3 over x minus 3 times x plus 4 times x minus 4, different squares. Look at that, x minus 3 divides x minus 3 to 1, x plus 4 divides x plus 4 to 1, x minus 4 and x minus 4 are 1, so the whole thing is 1. Some of you I saw multiply this all out and get the exact same polynomial, which of course you would, and then cancel out every single term. That's the same mistake as up here. Okay, not factors. Divide, whenever I'm dividing, I'll multiply by the reciprocal first. So reciprocal. Then we'll factor. So you get x plus 6 times x plus 3 over x plus 3 times x minus 3 times x minus 6 over x plus 6. And really what we have here is just this big fraction here. So we have these cancel and these cancel. We're left with x minus 6 over x minus 3. Simplify the rational expression. We have one fraction over another fraction. We don't want the denominators. So we'll multiply the numerator and denominator of this big fraction by, let's start with x minus 4. X minus 4. up here, the denominator and the numerator here, right, cancel out. So we're left with 4 over, and remember that when we multiply this through, we have to distribute it. So we wind up with 6 times x minus 4 over the x plus 2 times x minus 4. Now we still have this denominator of x, so let's multiply by x in the numerator and denominator. Multiply by x. So we get 4x over, we have to distribute this x too, so we get, well, when we distribute the x to this fraction, the x's cancel, so we're just left with 6 times x minus 4. That was the whole point, was to get rid of that x. But here we wind up with 2x times x minus 4. So now we have 4x over 6x minus 24 plus 2x squared minus 8x. And that is 4x over 2x squared minus 2x minus 24. This has a factor of 2 in the denominator. There's a factor of 2 in the numerator. It's 4x over 2 times x squared minus x minus 12. Right? And so the 4 and the 2 can divide each other. We get a 2. So we have 2x over x squared minus x minus 12. And we can factor this, but it's not going to have any common factors with the numerator, so I won't bother. We need a common denominator here, so we're going to multiply by x minus 2 in the numerator denominator. Here we need a common denominator, so x plus 2 in the numerator and denominator. So what's that leave us with? We've got 4x minus 8 over the common denominator, x minus 2 times x plus 2. And let's just say we know that we're going to have a common denominator. We're going to combine the numerators together. We're going to add them together. We get 9x plus 18. So we have 13x plus 10 over x minus 2 times x plus 3. They don't share any factors. I can't factor like a 3 or anything out of here, so they're not going to have any common factors. Remember, a factor in this situation would look like x plus 3 or x minus 2 or 13x plus 10. These are the factors. 5 is not a factor of the numerator. 13 is not a factor of the numerator. Okay, I'll let that go. We need a common denominator, so let's see what makes up this denominator here. We've got x minus 6, x plus 2, that works. So this needs an x plus 2 in the denominator here, so we have to multiply by x plus 2 in the numerator as well. So we have 2x squared plus 7x minus 36 minus x squared plus 6x plus 8. Let's just multiply these together and subtracting that from that. And we have this common denominator of x minus 6 times x plus 2. So we do our subtraction. We get 2x squared minus x squared is x squared. 7x minus 6x is positive x. Negative 36 minus 8 is negative 44. And that's all over x minus 6 times x plus 2. Next page, number 10. We're going to solve this by multiplying both sides of the equation by the common denominator. First, let's factor this to see if what the factors are. So x plus 4 times x minus 3. So multiply both sides by x plus 4 and x minus 3. That'll cancel this denominator, and the x plus 4 will cancel this denominator. X plus 4 times x minus 3 multiplied by x plus 4 times x minus 3. Now remember that when I multiply on the right side especially, I have to distribute both of these to these two terms, this term and this term. Okay, now on the left side we get the cancellation. We get x squared plus, is it plus? It's minus. X squared minus 3x. On the right side here we get both these factors canceling out with these two factors when you distribute them both to this first term. So that leaves us with 4x plus 2. When we distribute these two terms to this guy here, just the x minus 3's cancel. We're left with negative 2 times x plus 4. So we just continue on and can solve this equation as we normally would as a quadratic equation. Let's distribute that negative 2. And we'll move everything over to the left side there, x squared. We'll subtract 2x, so we get negative 5x, because we combine these together, we get 2x. Combine 2 and negative 8, you get negative 6. We'll add 6 to both sides, and there we go. we factor x minus 2, x minus 3 equals 0, so x equals 2 or x equals 3. Seems good, except for if x is 3, then this is 0, and this is 0 as well. So we get denominators of 0, so that's no good. This is extraneous. So x equals 2, that's our one solution. Okay, we'll solve this equation. Recognize that this is c plus 2 plus c, or times c minus 2. So we'll multiply both sides by c plus 2 times c minus 2, because this side has a c plus 2 factor in the denominator, which will get canceled out. Multiplying both sides by the lowest common denominator. On the left, we get everything cancels out. We're left with the numerator 8. Here, the c plus 2 and c plus 2 cancel. We get 8 times c minus 2. 8 equals 8c minus 16. We'll add 16 to both sides, and 8c equals 24. c equals 3. That's a good arrow. That's what we put right there. All right, here we're going to multiply both sides by the common denominator, j minus 2 times j minus 4. On this side, we'll just get 0. We don't even write that down. But when you distribute this to the first term, we get the j minus 2's cancel out. We get 1 times j minus 4. Distribute it here, the j minus 4's cancel out. We get minus 2 times j minus 2. All that equals 0. So we get j minus 4 minus 2j plus 4 equals 0. J minus 2j is negative j. Negative 4 plus 4 is 0, so negative j equals 0, so positive j equals 0. I believe that's all. That is all. All right, there you go. Thanks for watching. Hope that was helpful. If you have any questions, just let me know.